These are your 7.3b notes. We are now going to look at evaluating logarithmic expressions. So evaluate means give me a number that it equals, find out the value. It's not really an equation. We can write it as an equation. So that's one of the techniques really, is making an equation out of the exponential form of the logarithm. And so we're going to use our strategies of solving exponential equations where we get the common bases equal to each other, just for logarithms instead of exponentials. So if you look at this, there is no equation whatsoever. Okay, so you could write it as an equation, and remember, logarithms always equal the y value. So the regular form of this is log base b of x is equal to y. So you could bring in an unknown y value. You don't have to do that necessarily. You're trying to figure out what it equals. So if we change this into exponential form, you're asking yourself, what do you raise 3 to get 243? And you just created an exponential equation. Remember, anytime we want to solve for the exponent, it's called an exponential equation. So we rewrite 243 as a power of 3, which is 3 to the 5th, and then we have y is equal to 5. So pretty simple. You don't even have to write the equation. You don't have to bring in y. Basically, what they're asking is, what do we raise 2 to get 1/8? That's really what you're trying to do. And so then we're going to try to rewrite 1/8 as a power of 2. So you can leave it as a question mark. You can bring in the variable if you want. 1/8 becomes 2 cubed in the bottom. Then we got to flip it. So 2 to the y is equal to 2 to the negative third. And so y must equal -3. So we're sort of incorporating those exponential techniques, working with logarithmic functions. And then number 3, what are we raising 9 to? So 9 to the y. That will make it equal 3. Well, I got to make 9 into 3 squared to the y value is equal to 3 to the first. Don't forget that that's equal to something. It's to the first power. Power to a power we multiply. So it's 3 to the first. And then 2y is equal to 1. So y is equal to 1/2. So don't forget to bring that 1 in. 3 is being raised to something. It's not 0. And so when you go to set your equation for your exponents, you got to have it equal something. The next part, I can explain it a little bit better in class, but I just want you to get used to the habit that exponentials, exponents, and logs are inverses of each other. So they sort of undo each other, just like a square and a square root undoes each other. So I'm going to explain it in something that you understand. It has nothing to do with this, but hopefully that will help you wrap your brain around this and accept it. And then in class, I can show you how it works. It's just a little bit easier live. But if I asked you to square 5 and then take the square root of it, in the very beginning when you learned about square roots, you would have done the order of operations and squared the 5 and then taken the square root of it, and you get right back to 5. But as you got more and more comfortable with this concept, you'd realize that you're squaring and then square rooting, they undo each other. They're inverses of each other. So you don't have to do anything. You just sort of cross it off, and you know you'll get back to the base. The other thing, if I said to take the square root of 5 and then square it, I don't actually get my calculator out and take the square root of 5 and then square that ugly decimal back. I'll get 5. So this is just the same two functions, square roots and squaring, just in the opposite order. But we've learned that they just cancel each other out, and you'll eventually end up with 5. So that's sort of the basis behind these things. So if you're taking a number, a base 2, and that's being raised to the log base 2 power. So logs are powers. And so you have a base raised to a log as the exponent. So you're writing an exponent with logs. They're inverses of each other. And notice that the two bases are the same. This is simply going to become 8. I will show you in class why that is. It's just a little confusing, and I don't want to do it right now. So when you see things written that way, just get in the habit of crossing them out and calling it 8. And then the same thing goes for logs. If you have a log of a base, raised to a power of that same base. So now you have a log written in terms of a power. You see those two threes, you got to get in the habit of crossing them off and just calling it 7. I'll explain that in more detail tomorrow, but right now I just want you to get used to that idea. It's sort of the same thing I just showed here. You don't really have to do all the evaluating. In the end, you're going to get those answers anyway because they're inverses of each other. We got a freebie for our lesson summary, and I need you to evaluate log base 7 of 49. Good luck.